You know the feeling. You wake up, and for a split second, the memory is right there. It's vivid. It's coherent. You just spent 3 hours in a neon-lit underwater city discussing philosophy with a golden retriever. It made perfect sense at the time. But then, you open your eyes for a moment. You blink, and it's gone. It doesn't just fade. It evaporates. It's like trying to hold on to smoke with your bare hands. You can't grasp at the details. Was the dog wearing a tie? But the harder you try to remember, the faster it dissolves. Within 5 minutes of waking up, 50% of your dream content is gone. Within 10 minutes, 90% is deleted forever. It feels like a glitch, a failure of your memory, but it's not. What if I told you that this amnesia isn't an accident? That your brain isn't failing to save your dreams? It's actively, deliberately deleting them. It turns out there's a biological delete button in your head, and the reason it exists is actually kind of terrifying. If you remembered your dreams, you might lose your grip on reality. To understand why we forget, we have to look at what's actually happening in the engine room while you're asleep. We tend to think of sleep as a time when the brain shuts down, a system power off. But that's not really true. During REM sleep, rapid eye movement sleep, your brain is actively burning almost as much energy as it does when you're awake. If you looked at an fMRI scan of a dreaming brain, it lights up like a Christmas tree. The visual cortex is generating imagery. The motor cortex is firing commands to run, jump, to fly. The amygdala is processing fear and emotion at high volume. To the internal observer, the experience is real. It is chemically indistinguishable from reality. So, you have this incredibly intense, high-fidelity experience, and yet, the moment you wake up, the record is wiped clean. This brings us to the first culprit in our mystery, the neurochemistry of the save button. Memory isn't magic. It's chemistry. Specifically, it requires a cocktail of neurotransmitters to take a short-term experience and encode it into long-term storage. Two of the big players here are serotonin and norepinephrine. You can think of norepinephrine as the ink your brain uses to write memories down. It's essential for focus and for cementing new information. When you are awake, these levels are high. When you are deeply asleep, they crash. But during REM sleep, when your most vivid dreams happen, your brain enters a very weird state. Acetylcholine, the chemical that helps with attention and imagery, spikes through the roof. That's why dreams are so visual. But norepinephrine, it hits rock bottom. It is essentially absent from the cerebral cortex. So here's the situation. Your brain is generating a blockbuster movie. The projector is running, the audience is seated, but the camera that's supposed to be recording the event has no film in it. You are streaming the data, but you aren't downloading it. This is why you can remember a dream if you wake up during it. The shock of waking up causes a sudden flood of norepinephrine, essentially putting ink back into the printer just in time to catch the last few seconds of the image. But if you transition naturally out of REM sleep and into a lighter stage before waking, the chemical tide has already gone out. The memory was never written down in the first place. It's not just about the chemicals, though. It's about the hardware. The hippocampus is the part of the brain responsible for sorting memories and filing them away. It's the librarian. When you wake up, the rest of your brain comes online pretty fast. Your sensory processing, your motor control, they snap to attention. But the hippocampus? It's a slow starter. It takes a few minutes to fully boot up and start communicating effectively with the rest of the cortex. So in those first groggy moments of the morning, you have a window where your conscious mind is awake, but your memory recorder is still buffering. This is why distraction is the enemy of dream recall. If you wake up and immediately look at your phone, or think about coffee, or worry about the email that you didn't send, your brain prioritizes that new sensory data. The fragile, unencoded dream signals get overwritten by the loud signal of reality. It's like trying to listen to a whisper in a room where someone just turned on a leaf blower. For a long time, scientists thought that this was just a passive failure. We forgot dreams because the conditions weren't right to save them. But new research suggests something more active is going on. Your brain might be trying to make you forget. In 2019, a study out of Japan focused on a specific group of cells in the hypothalamus called melanin concentrating hormone neurons, or MCH neurons. These cells are active during REM sleep, and they discovered that these cells seem to actively inhibit the hippocampus. They basically tell the memory center, do not record this. When they activated these cells in mice, the mice forgot what they had learned. When they turned them off, the mice's memory improved. This suggests that dreaming involves a phase of active clearing, a garbage collection cycle. Why would evolution do this? Why spend all that energy creating dreams only to pay special neurons to delete them? Well, imagine if you remembered every single dream you ever had with the same clarity as your waking life. You'd have thousands of memories of flying, of monsters, of conversations that never happened. Over time, your brain would become cluttered with false data. You might start to struggle to differentiate between the memory of a real conversation with your boss and the dream where your boss was a giant grizzly bear. This is the overfitting theory. The idea is that dreams are a way for the brain to process emotions and run simulations. But the data from those simulations is just junk. It's noise. So, the MCH neurons act like a bouncer at a club. They let the experience happen, but they make sure it doesn't leave the building. There is one more layer to this, and it explains why dreams feel so profound when you're in them and so nonsense when you wake up. When you're dreaming, your prefrontal cortex is largely offline. This is the part of your brain responsible for logic, reason, and linear time. It's the adult in the room. With the adult asleep, the rest of the brain is like a bunch of toddlers in a sandbox. Anything goes. Gravity? Optional. Plot consistency? Who needs it? Because the logic center is offline, you accept the absurdity of the dream as total reality. You don't question why you're taking an exam in your underwear, you just feel the anxiety of it. And when you wake up, the prefrontal cortex snaps back online. It looks at the lingering fragmented images of the dream and says, "This is garbage. This doesn't make any sense. Discard it." It's possible that we forget dreams partly because our waking brain simply rejects them as illogical. They don't fit the narrative structure of reality, so they get tossed out. So, the system is rigged against you. The chemistry is missing, the hardware is lagging, and there are specific neurons trying to hit the delete key. But what if you want to remember your dreams? You don't need to drink a gallon of water before bed or set alarms at 3 a.m. You just need to change how you wake up. The most effective method is called Hypnagogic Replay. When you first wake up, do not move. Literally, stay physically paralyzed. As soon as you move your muscles, you send a massive wave of sensory feedback to your brain that flushes the short-term memory buffer. You ground yourself in the physical world and the dream world disconnects. So, stay still. Keep your eyes closed. And instead of trying to remember the whole dream, just grab onto the last feeling you had. Were you scared, happy, confused? Focus on that emotion. Usually the emotion is the anchor. If you pull on that thread, fear for instance, an image will pop up attached to it. I was scared because there was a shadow. Then you pull on the shadow. The shadow was in my childhood home. You can reconstruct the dream backwards from the end to the beginning, before the chemistry fades. And then, and this is the annoying part, you have to write it down immediately, because even if you recover the memory in bed, that low norepinephrine state means it won't stick around for breakfast. There is a certain beauty in the fact that we forget. It suggests that dreaming isn't about the result. It's about the process. It's a nightly therapy session, a data sorting algorithm, a creative playground that is meant to be experienced in the moment and then let go. Your brain isn't broken. It's just protecting you. It's keeping your reality pristine by washing away the sketches of the night. But every once in a while, it's nice to wake up, grab a thread of that vanishing world and pull it back into the light, just to see what your mind is capable of when the logic circuits are sleeping. If you like this video, check out the video in the description about why our dreams feel so important even when they're absurd. If you want more content like this, please like and subscribe. Thanks for watching, be kind to each other, and take care.